The scanning workflow. But how do I scan? In which catalogue? Always scan the opposing jaw as a whole jaw. See the scan pass as described above. The preparation scan should happen in such a way that before preparation, before anesthesia, we scan only briefly up to the tooth that is to be prepared. The prepared tooth is then scanned further after the treatment. That is, we then finalize the scan. The buccal bite catalogue should always be performed on both sides, in the area of the premolars from gingiva to gingiva, like this plaster. Do not extend from mesial to distal. It is important to keep the patient in the correct bite position with a fixation grip. A good explanation is in this video. Scan catalogues can be used like caches to park data. For example, always park the initial scan in this additional cache catalogue. This has the advantage if you noticed after the preparation or after the complete scan that you still have some work to do. You have not yet used up this old scan. This means that if you have copied it into an additional folder, you can delete the already completed scan and copy it back fresh into the preparation jaw in order to complete it again after correcting the preparation. Cutting and rescanning is generally not recommended, as Leandro Passo's study has shown us. It is better to rescan. Unnecessary data should be removed. It would be like a fluttering edge afterwards. Cheek areas or anything protruding above the occlusal surface should be cut out. The example of crown 1/6 FDI. First we make a copy from 1/7 to 1/3 and possibly even more. Then we scan the upper jaw between 2/7 to 1/5 and no further. Then we copy this catalogue into the gingiva as a cache. Fourthly, we scan the opposing jaw as a whole jaw. We register the bite, and if necessary, we continue with the model phase and save it at least manually. Now we anesthetize and prepare 1/6. If necessary, we go back to the recording phase. Then we scan 1/6 and 1/7. Briefly check if we have enough space or if preparation is necessary. If necessary, we correct the preparation of tooth 1/6 and delete all data in the upper jaw catalogue and copy it again from the gingival catalogue. There is then no incorrect data from the first prepared tooth 1/6. Now an extended scan again in the maxillary preparation catalogue. We can continue in the construction and complete. Tips and tricks. It is important to always find already scanned areas. It is best to go back to the last point or to the starting point or all over again. Principles and preliminary remarks. Always scan as early as possible. It saves time. Edge during preparation, but leave the bite unaffected. Always keep track of how it was. Activate the articulator and possibly oral check later. Allow corrections from the preparation and allow re-scanning. As fast, as flexible and as much overview as possible, if possible, all together. Scans are rendered in the background. The prime scan automatically decides uncontrolled for itself which image part is taken and which is not. The same goes for cropping. A lot of data also means a lot of data rubbish. The catalogues would be assigned to the jaw, per jaw correlated. Important basic facts. Structured surfaces are captured better than smooth surfaces. Glossy surfaces are poorly captured. For this, we can use the scan spray. A very light spray, and we mat our metallic surface very thinly and can scan much better. Moving material is difficult to see, such as the free gingiva, the cheek, and so on. To deal with bleeding, take special care that the first scan of the area is good. Blood is only bad on the first scan. It doesn't matter on the rescan. This is what the scalp calculates out. Teeth are preferred by the algorithm. Take the thumb as an example. Here we see the different possibilities. The old bottle and the new bottle of Ceric OptiSpray. Shiny surfaces sometimes need a very light powder. Another possible tip in the area of tissue managing is the retraction paste or thread, a twisted Teflon tape that is placed in the sulcus or even a laser treatment. Milling modes. Welcome to the module to learn about the milling modes of prime mill. Which milling modes do we have available? For which situation? And when do I use which one? Let's begin with an overview. The aim of this presentation is to learn how to choose the right milling mode depending on the material and the requirements. Which tools are available to us for this and which technical aspects have to be considered. The milling modes and their material groups. We have 4 material groups that require different machining depending on the material. For a better subdivision, we orientate ourselves on the already existing colors. On the one hand, we have the silicate ceramic, which we show in yellow. And as a rule, it has to be glazed, crystallized, or finalized. The second large group, shown in light blue, is zirconium oxide. It always has to be sintered and can optionally be glazed. The third group, shown in purple, are the hybrid ceramics. They must never be sintered, crystallized, or finalized in the furnace, just polished. The last group are the acrylates, shown in grey. They too must never be crystallized or glazed or finalized in the kiln. Let's take a look at the different milling modes. There is the super fast dry mode, which is exclusively for zirconia milling in dry mode. Secondly, there is the fast mode in wet and dry. It is available for silicate ceramics in wet, hybrid ceramics in wet, acrylates in wet and zirconium in dry. The third mode is the fine mode. This is reserved for silicate ceramics in wet, hybrid ceramics in wet, and also for zirconium oxide in dry. We also have a fourth mode with extra fine. We can use this for zirconium oxide dry, acrylates wet, and hybrid ceramics also wet. Let's take a closer look at the features of the superfast milling mode. Superfast is reserved exclusively for zirconia. The focus here is clearly on speed. Here we are at a very high precision rate, despite the speed due to the parallel grinding and milling process. We will still get smooth edges without chipping, and the surfaces are rendered precisely and in great detail despite the speed. It is exclusively for zirconia and requires an edge enhancement of 100 without setting the 100 microns edge reinforcement. Milling in superfast mode is not possible. The milling process takes less than 5 minutes. We have a single connector and we can use it exclusively in the dry process. What are the attributes of superfast mode? In superfast mode, it is very special because both motors run in a controlled parallel mode. All axes are moved so that both the left and right motors hit the same spot on the workpiece. It was a feat of engineering to develop this. The stability of the material is created by slight parallel pressure. Both motors are always equipped with identical tools called twins. This gives us high speed and no significant loss of quality. With zirconium oxide in particular, it is so special that we have a sintering process. Because of the sintering process, these small edges, which are perhaps still visible to the naked eye, also melt after sintering. Milling mode fast. Here the focus is clearly on speed and attention to detail. So, there is even more detail in the milling surface than in superfast mode. Features. Again, we need an edge gain of at least 100 microns. The fast mode also accepts lithium disilicate ceramics, so it is not exclusively reserved for zirconia. We therefore find a mode that also allows a very fast grinding time for silicates, namely reduced by 40%. Patients can therefore be treated with even higher quality, more aesthetic restorations and yet extremely quickly. More complex cases can therefore be carried out very efficiently chairside. In addition to this, we have the highest quality, which results in perfect restored edges. We have a very smooth surface procurement for extremely precise results. Here we find an overview table of the possibilities of each grinding mode. First of all, here is the fast grinding and milling mode. We can see in each case the different manufacturers and materials and which modes, dry or wet, are available to us. The fine grinding mode. Here the focus is absolutely on the detail. This mode is applicable on all grinded and milled. Here we have more detailed surfaces than in the fast mode. However, the grinding and milling time takes a little longer here, but it is still possible to have a simple work time in the single visit situation. Because here, the grinding and milling times are still within an acceptable time frame. Here is an overview table of the fine grinding mode. Here too, you can see by the manufacturer and their material whether this material can be dry or wet grinded or milled. Let's move on to the last milling mode, extra fine. In extra fine milling mode, we have the focus on absolute fine detail. We need extra tools for this. The tool paths are calculated according to the construction of the restoration. The superfine mode allows us to create very detailed fissure representations and also better elaborations in the interdental spaces of the bridges. This results in a higher data density, which of course is only possible at the expense of production speed. We will no longer need twice as much time as was previously necessary in the MCXL, but it will still take considerably longer than in fine mode. In this extra fine mode, you can work out the finest surface structures. Reworking is then definitely no longer necessary. The extra fine option gives the glass ceramics absolute fine fissures, completely smooth surfaces, more detailed corners, and more precise edges in areas with more irregular shapes. And we have a really improved interdental finish in the bridges. For very fine grinding geometry, we have a new diamond grinding tool for this. We can use this in wet grinding mode for glass and feldspar ceramics, as well as for hybrid and acrylics. A brief overview of the materials that can be finalized with the milling mode extra fine option. In feldspar ceramics, there are the Ceric blocks, the Vita Mark II, the Vita Trilux, and the Vita Real Live. In lithium disilicate ceramics, Emax CAD, Vita Supranity PC, Celtra Duo, and of course Ceric Tessera can be milled. In glass ceramics, it is available for Empress CAD and Ceric Blocks C. And in hybrid ceramics, for Lava Ultimate, Cerasmart, and Vita Enamic. Here too is an overview table of which manufacturer and which material we can select dry or wet mode for. What hardware and software requirements do we need? It is only possible with 4-motor milling machines. It works with Ceric software 5.1.1 and higher. We do not need an engine upgrade for this. The extra fine milling machine requires a torque spanner with a triangular opening. We have extra grinding tools for this mode. For the left side of the machine, we have the Step Burr 12S or the Step Burr 12 Plus or the Burr 12 Extra Fine. For the right side, we have the Pointed Burr 12S Plus or Pointed Burr 12 Extra Fine. Important is, the extra fine grinders must always be placed in set 1, and the standard grinders must always be placed in set 2. An example of the extra fine tools. Above, we see a cylinder drill 12EF. It has a diameter of 0.9 mm, a ball radius of 0.46 mm, and a grain size of D54. Below, we have a cylinder point drill 12EF, diameter 1.18 mm, ball radius 0.34 mm, with an angle of 30 degrees and a grain of D46. The grinding time for extra fine grinding is approximately twice as long as for fine grinding. The new tool with the 0.5 mm tip for occlusal, approximal areas and details ensures the finest fissures, and especially in the areas with bridge elements, for perfect finishing. The focus is definitely for precision at a reduced speed. Different sets are available. Tool sets and technical aspects. Here we have an overview of the tools. One is the set for grinding zirconia and milling. The set is for milling zirconia extra fine, milling zirconia superfast, milling PMMA and grinding, and milling PMMA extra fine, and also burrs, diamond burrs, and carbide burrs. We will divide these into milling tools and grinding tools. Milling tools are for zirconia, PMMA and all other requirements. Grinding tools are for fast and fine and extra fine. There is a complete table of all the tools to look at. They are available to download from the Dentsply Sirona Ceric Primal tool table at myceric.com and can be looked up at any time. The new RFID tool management system is used for the secure administration of all grinding and milling tools. They are readable and immediately recognize whether they are correct for the corresponding grinding mode. The data is integrated on a color-coded cap at one end of the tool, which is adapted to the color concept of the in-lab MCX5. Yellow zirconium, black multifunction, red PMMA and green titanium. Only the data from the instruments are stored in the chip, that is, manufacturer, type, lot number, length, etc. The special thing about the Primil and its tools is that if the calculated service life goes to 0, the process is not aborted but still carried out to the end. It is calculated beforehand whether the existing tool can still perform this grinding or milling operation. The capacity and remaining service life of the individual tool is given as a percentage and is calculated as the sum of the individual usage processes in the past. For example, how many modes has this tool already gone through? How many grinding processes, in what duration, in what size, and what materials have been used? So it depends on how many large, small, hard, or softer materials have been processed. If the instrument calculates that the capacity of the milling tool is no longer sufficient for the next grinding or milling process, the instrument can no longer be used for this purpose. The only exception to this is if the instrument breaks. Then, the instrument must also be changed during a grinding or milling operation. A special feature is that the correct tool is shown directly on the display. This is a major advantage over the Ceric MCXL, where a required tool change leads to an interruption of the grinding process. When changing, it is displayed exactly where the respective cutter or grinder belongs. Incorrect insertion is practically no longer possible. The position of the motors is guided by a tool managing process in such a way that the motors move into a new position compared to the Ceric MCXL, so that you can no longer injure yourself on used grinders and milling cutters. In the Ceric Prime Mill, there is an integrated block scanner that reads the applied data matrix code of the individual block and immediately takes into account all information about manufacturer, material, block size, color, and in the case of zirconium oxide, the magnification factor. Many blocks are currently not provided with a data matrix code. Until then, you can easily call up the selection in the menu navigation and enter the block information manually. However, in the future, this information will certainly be available to be processed directly. This is already important for the enlargement factor. We no longer have to enter the information manually for a zirconium oxide block. In addition, all information is matched. This means that if I have selected a different material in the administration on the prime scan than what I wanted to use, it will immediately give me an error message when to use dry or wet milling mode. The high precision and finer, improved surfaces are achieved by a higher subdivision of the individual steps of the stepper motors. These individual steps, full steps, are specified by the division of the encoder discs on the shaft ends of the motors. At the MCXL, these full steps were divided into 1/8 steps, at the Primel in 1/64. This results in an 8-fold higher resolution of the Primel compared to the MCXL for the curved paths of the rotational movement and feed movement of the linear axis. Milling mode, dry or wet. The dry milling option ensures sharper edges when working on zirconia without the risk of chipping. The dry milling option ensures that we can also realize zirconia restorations in single-visit dentistry. Dry milling saves you the drying time of your zirconium oxide restorations. When machining polymers, you also benefit from the wet milling option through more stable machining, shorter processing times, and glossy surfaces. The qualities between wet and dry milling, the accuracy and detail, are identical for both processes. Also, there is no time difference between wet and dry milled restorations. Only the pre-drying time during the sintering of zirconium oxide is to be considered for wet milled restorations. However, we simply have more beautiful aesthetic results by dry milling with multi-layer zirconia. Thank you very much.